Right? Can you see?
Yes, monk.
हम्म तो ये एनसीईआरटी की बुक है और ये 2025 टू 2026 2025 टू 2026
Yes,
ईयर
monk.
का रीप्रिंट है
Hmm.
और ये अगर मैं दिखाऊं so you can see physics part 1 textbook for class 11th national council of educational research and training राष्ट्रीय शैक्षणिक अनुसंधान और परीक्षण
Parishad.
प्रशिक्षण
हाँ,
प्रशिक्षण
प्रशिक्षण
परिषद
परिषद. Hmm.
reprint at 2025-26 right
Yes, monk.
okay so it's captured and you can look at the book in the beginning so in the free time you can explore the preface
Okay,
right
monk. Yes.
so it's a good habit to read the preface just for habit's sake when you get a time take it as an
Hmm.
assignment that you will read the preface.
Done, monk. I will do it.
Okay, so assignment number one. So in this, we can take notes also. In this meeting, team meeting, we can take
Hmm.
notes also. Let's see how do we take notes. Assignment one, read the
Okay.
preface. It is a good habit to the preface of a book. So this should make it clear. The file is saved. Okay, now let's move on.
Yes, monk.
So look at the table of contents.
First unit and measurements.
First chapter is units and measurements, and
Yes, monk.
this is the pages behind this. And I will share the PDF of this class after the class is over, and I'll also share the link to the video. So let's begin. Om Gam Ganapataye Namaha. Jai Shri Ganesh.
Om Ganapataye Namaha.
Units and measurements. So introduction: the International System of Units, significant figures, dimensions of physical quantities,
Hmm.
dimensional formulae and
Hmm.
dimensional equations, dimensional analysis and its applications. So, now, would you mind repeating the table of content from 1.1 to 1.6?
Yes, monk. So first is introduction. The second one is the international system of units. The third one is significant figures and dimension of physical quantities, dimensions of physical quantities. The next one is dimensional formulae and dimensional equations, and the last one is dimensional analysis and its applications.
Great, thank you. So, now let's begin. So, we'll not read the whole table of content
NCERT.
because that will
Yes, ma'am.
consume time. So now let's focus on chapter one. And in your free time, uh, make it a point that you take a glance at each item, right? Each
Yes, ma'am.
item in the table of content. That
Hmm.
will give you the roadmap that what all we are going to study in class 11th. And we'll target to finish the class 11th in 6 weeks, or let's say 7 weeks, because there are 7 chapters. Let's try to
Yes,
target
ma'am.
7 weeks.
Okay, ma'am. Ma'am, there are two parts of the book, physics, part one and part two. So there are total 14 chapters.
Okay, good to know. We can look
And
at the sec.
chemistry, yes, and chemistry has the same owner two books with same 14 chapters, part one and part two.
Good to know. So we will do one thing. We will make a checklist, and
Okay, ma'am.
so checklist like this. So and then we'll check it once we are done with the thing. And then this way we'll check mark the whole PCM, physics, chemistry, and math.
Yes, Monk.
And for that, we'll think of a timeline. So you are welcome to think of that timeline for yourself. So let's see, based on how fast we go. So 1, 2, 3, 4, 5, 6. So based on how fast we go here in this chapter 1, we'll come to
Yes,
know
Monk.
we'll come to know what is our pace, what is our speed, right?
Hmm. Hmm.
Idea is the goal is to learn as much as possible, right? So
Yes,
let's
Monk.
begin.
Okay, Monk.
So whenever you begin something good, you begin with a Mangala Charana. So we already
Yes, Monk.
did Om Gam Ganapataye Namaha Jai Shri Ganesh. That is our Mangala Charana
Hmm.
and chapter 1. So units and measurement. 1.1 Introduction. So would you mind reading the whole paragraph? This one paragraph?
Yes, Monk. I will read. Yes, Monk.
I'll
So,
make it bigger for you.
1.1. Yes, Monk. Introduction. Measurement of any physical quantity involves comparison with a certain basic, arbitrarily, arbitrarily chosen, internationally accepted reference standard called unit. Yes. The result of a measurement of a physical quantity is expressed by a number or numerical measure, accompanied by a unit. Although the number of physical quantities appears to be very large, we need only a limited numbers of units for expressing all the physical quantities. Since they are no they are interrelated with one another. The unit the units for the fundamental or base quantities are called fundamental or base units. The units of all other physical quantities can be expressed as combination of the base units. Such units obtained for the derived quantities are called derived units. A complete set of these units, both the base units and derived units, is known as the system of units.
Right. Well read. So I will read it for you once uh, with loud enough voice just to
Yes,
ensure
Mark.
that you get the pronunciation. So it's a good habit to
Okay,
read, and it's a good
okay, Mark.
habit to read aloud. So it actually guides you and builds your public speaking acumen, right?
Mm.
So let's do that.
Yes, Mark.
Measurement of any physical quantity involves comparison with a certain basic, arbitrarily chosen, internationally accepted reference standard
Mm.
called unit. The result of a measurement of a physical quantity is expressed by a number or numerical measure accompanied by a unit. Although the number of physical quantities appears to be very large, we need only a limited number of units for expressing all the physical quantities since they are interrelated with one another. The units
Mm.
for the fundamental or base quantities are called fundamental or base units. The units of all other physical quantities can be expressed as combinations of the base units. Such units obtained for the derived quantities are called derived units. A complete set of these units, both the base units and derived units, is known as system of units, right?
Yes, Mark.
So let's break it down. So whenever you read something big, so this is a good enough, big enough paragraph, right?
Yes, Mark.
So whenever you read something big enough, you break it down to understand it, right?
Mm. Yes, Mark.
And after understanding it, after breaking it down, you integrate the understanding into one unit, and that's how you understand a big thing.
Hmm.
So when you go further, let's put that in Hindi. जब हम कोई बड़े प्रोजेक्ट करते हैं तो प्रोजेक्ट मैनेजर्स क्या करते हैं कि उस प्रोजेक्ट को वर्क ब्रेकडाउन स्ट्रक्चर से ब्रेक डाउन करते हैं और एक एक ब्रोकन पार्ट को अच्छे से समझ के उन सब के सॉल्यूशन को आपस में फिर इंटीग्रेट करके कंप्लीट सॉल्यूशन बन जाता है, राइट? सो
Yes,
लेट्स
monk.
ब्रेक इट डाउन. Measurement of any physical quantity involves comparison with a certain basic. So measurement of physical quantity means what?
Monk, which we can see or touch, like chair, table, any like these objects.
Right. And physical quality?
Physical quality is physical anger.
Yeah, those things that might not be seen with the eyes, smelled with the
Hmm.
nose, touched with the skin, uh, sm- uh, tasted with the tongue, and
Yes,
what?
monk.
And smelled with the nose.
हाँ.
सो ये
Yes.
5 तत्व जो होते हैं उनके माध्यम से जो परसीव कर सकते हैं वो होती है फिजिकल, ठीक है? और
Hmm.
क्वांटिटी होती है वो जो मेजर की जा सकती है, जो नापी जा सकती है. यहाँ पे मेजरमेंट है ना. तो
Yes, monk.
मेजरमेंट ऑफ एनी फिजिकल क्वांटिटी इन्वॉल्व्स, क्वांटिटी का ही मेजरमेंट हो सकता है. क्वालिटी का मेजरमेंट करने के लिए यू हैव टू यूज सर्टेन टेक्निक्स. सो विल टॉक अबाउट दोज
Hmm.
टेक्निक्स आल्सो. दैट्स लाइक क्वालिटेटिव टू क्वांटिटेटिव. But now we are talking about quantity. So this quantity is a useful word. Involves comparison with a certain. Certain, I have captured the word certain here. You see certain?
Yes, monk. I can see.
The certain is important. Certain is important to understand that the the unit that we are defining here. This sentence is the definition of unit, right?
Hmm.
So to
Yes, monk.
define something, we kind of tell about it, and the things that we tell, those are like bullet points, points that we kind of remember to know
Hmm.
about that
What to
thing,
remember?
right? So certain is important. Basic, it should be fundamental, it should be very simple, like basic, right?
Yes, monk.
Arbitrarily chosen, it's not that arbitrarily means it's not specified by certain thing, or it's chosen arbitrarily, and once you choose it then you stay with it. That's what is meant by arbitrarily.
Oh,
मतलब
one time, only one
हम्म
time you can choose.
हाँ, चॉइस पहली बार मिला उसके बाद यू फिक्स इट. तो फिक्स करने वाली
Oh.
बात आगे आएगी. सो आर्बिट्ररली
Hmm.
चूजन, इंटरनेशनली एक्सेप्टेड. चूज कर लिया और इंटरनेशनली लोगों ने एक्सेप्ट कर लिया.
Hmm. Hmm. Hmm.
तो चूज हुआ और लोगों ने एक्सेप्ट नहीं किया तो फिर वो नहीं बन पाएगा यूनिट. Arbitrarily chosen, after it is chosen it should be internationally accepted, and it should be
Okay, monk.
reference standard. रेफरेंस करने के लिए अगर किसी को कोई चीज जाननी होती है तो दे रेफर टू सम सोर्स, राइट? सो दिस विल
Yes,
बिकम,
monk.
this unit, the thing that we are talking about, unit, it will become a reference standard for everyone
Hmm.
to reference and look at it and see, okay, we will use this unit. So it's that thing. The certain
Okay.
basic, arbitrarily chosen, internationally accepted reference standard. That is the unit, right? So
Okay.
I'm not emphasizing rote learning or memorizing, but I'm
Hmm.
giving you a technique to memorize, because in exams, when they ask about definitions, we usually they don't do, but mostly definitions are things that we remember or memorize. And
Yes, monk.
we try to limit our memorization to very few things, and the things that we must memorize, we'll use certain techniques for that, right?
Okay, understood.
So when we break down, the first sentence is the definition of unit. We kind of understood it. If you have any questions, you can ask.
No, proceed. You can continue.
Okay, I'll drink some water. Next sentence, the result of a measurement of a physical quantity is expressed. by a number or numerical measure accompanied by a unit, right?
Yes.
So, would you mind describing its meaning and probably in English?
Uh, Let me try. The result of a measurement of a physical quantity is expressed by a number or numerical measure accompanied by unit. So, when we measure a physical quantity, when after the measuring the physical quantity, we can express it by a number, which is given by which we can express it in a number, in a numerical measure accompanied with the unit.
For example,
For example, if we are measuring the distance of a road, so we can say that this road is 10 kilometer long. The kilometer is the measurement, the kilometer is the unit, and the 10 is the numerical measure.
perfect. Well done. So, let's move on. Although
Okay.
the number of physical quantities appears to be very large, we need only a limited number of units for expressing all the physical quantities since they are interrelated with one another. Can you try to describe it?
Yes, Mark. Although the number of physical quantities appears to be very large, we need only a limited number of units for expressing all the things. Yes, Monk. For example, let's take an example. Although the number of physical quantities appears to be very large. Okay, if there is a big jar which is full of some liquid things like water, and if we have to describe it, if we have to take the measurement and to describe it, we can use limited units like liter, milliliter to describe it in a small and easier way, like this something.
Right. So you can have very well tried. Is your mic okay? Is your connection okay?
Yes, one.
Okay, nice.
Any issue?
No, no issue. So here is a good example would be oil is a
Hmm.
some oil is a physical quantity and some water is a physical quantity. And you will use the liter to describe both the physical quantity, right?
Yes, one.
So they are interrelated in terms of uh, the property of a liquid, right? So
Yes, one.
that way they are interrelated,
Hmm.
and we need only liter to describe its physical quantity. Either it is oil,
Okay.
cooking oil, or engine oil, or water, or any liquid can be described with liter. So this is, I think, what they are
Oh,
trying to convey here. Hmm.
oh, understood, monk. We
Right.
can describe all the example of oil like cooking oil, engine oil in the use by using only one unit.
Right. And number of physical quantities appears to be very large. So number of physical quantities means what? So physical quantities could be, yeah, as you described it well actually. I think you are right, more right than my understanding. So your
Hmm.
understanding is that even you could have like several milliliters, liters, uh,
I will
metric
recheck it.
liters, yeah,
Yes, monk. I
different
will recheck it.
quantities.
Recheck it. Yes,
Yeah.
monk.
Many quantities are possible, but only you need a few units to describe those. Yeah,
Hmm.
because these units are
Certain
also
units will describe certain things.
right. The units for the fundamental, let's move on. So the units
Yes, monk.
for the fundamental or base quantities are called fundamental or base units, right?
Yes, monk.
So base quantities are described with base units, fundamental units. We don't have examples in introduction here, but we'll find examples later.
Okay, monk.
The units of all other physical quantities can be expressed as combinations of the base units. Such units obtained for the derived quantities are called derived units. So there are base units and derived units, and the complete set of base units and derived units is called system of units. So let's start.
System of units.
Yeah. So limited number of units, since they are
Hmm.
interrelated, fundamental base units, quantity is equal to base units. Base
Hmm.
plus derived units is set or system of units. So it's
System
simple
units. Okay.
short notes.
Hmm.
Okay, now read this paragraph, and we have like 17 more minutes to go. Read this paragraph.
Oh, okay. So, the international system of units. In earlier times, scientists of different countries were using different systems of units for measurement. Three such systems, the CGS, the FPS or British system, and the MKS system, were in the use extensively till recently. The base units for length, mass, and time in these systems were as follows. In CGS, in CGS system, they were centimeter, gram, and second, respectively. In FPS system, they were foot, pound, and second, respectively. In MK system, they were meter, kilogram, and second, respectively. The system of units, which is at present internationally accepted for measurement, is the System Internationale Unites, French for International System, French for International System of Units, abbreviated as SI. The SI, with standard scheme of symbols, units, and abbreviations, developed by the Bureau International des Poids et Measures, the International Bureau of Weights and Measures (BIPM) in 1971, were recently revised by the General Conference on Weights and Measures in November 2018. The scheme is now for uh, yeah, the scheme is now for international usage in scientific, technical, industrial, and commercial work. Because SI units used decimal system conversions within the systems are quite simple and convenient. We shall follow the SI units in this book. In SI, there are 7 base units as given in the table 1.1. Beside the 7 base units, there are 2 more units that are defined for A. Plane angle, D, what this sign called? Mm, I forgot, man. What is the name of this sign?
D theta.
Which is
D theta.
yes, ma'am. Yes, ma'am. D theta as the ratio of length of R, ds to the radius R, and B solid angle d ohm as the ratio of the intercepted area dA of the spherical surface, described about the apex O as the center, to the square of its radius R, as shown in figure 1.1, A and B respectively. The units for plane angle is radian with the symbol rad, and the unit of the solid angle is radian with the symbol SR. Both these are dimensionless quantities.
Right.
Not too good.
No, it's good enough. And it's a lot, right? So we have to break it down quickly.
Yes. Hmm.
So let me give you a quick example of how to break it down. So it's already broken down to a
Okay.
large extent, small paragraphs, right? So in earlier time, scientists of different countries were using different systems of units for measurement, right?
Hmm. Yes, ma'am.
So, so the three such systems, the CGS, the FPS or British system, and the MKS system, were in use extensively till recently. So
Yes, ma'am.
these are different systems used by different cultures. And there's the anecdote regarding this problem. So different countries using different measuring systems. So what is the problem? I mean, why is the problem? So they are saying that the system of units which so the base units for length, mass, and time in these systems were as follows. In CGS system, they were
Yes, monk.
centimeter, gram, and second respectively. In FPS system, they were foot, pound, and second respectively. In MKS system, they were meter, kilogram, and second respectively. So so they needed to the system of units which is at present internationally accepted for measurement is the Système Internationale Unities, French for International System of Units, abbreviated as SI. So they say that they came up with internationally accepted instead of choosing their respective. They came up with internationally accepted. Why did they need standardization and one common system?
Monk to they need this standardized system to differentiate between differentiate between the units to make it more simple to know.
Mm, so see, uh, what I'm asking is there were
Yes,
multiple different systems, different countries. See, it's saying different countries were using different systems of units, and
yes, monk.
at present they are using internationally accepted measurement, right?
Hmm.
And
Yes,
it's
monk.
developed by this International Bureau of Weights and Measures BIPM
Yes,
in
BIPA.
1971
Yes. Hmm.
and revised recently by a General Conference on Weights and Measures in November 2018. So why did they need to in- come to one common internationally standardized accepted system? Why did they need that?
Yes, monk. Because yeah, there are many problem consequences which can which are raising. For example, if a trader weighs his products or the carrying object in the other country, the system of measuring in the other country is different. And if they're transporting their trading objects to the other country, the measuring weighs, the system is different. So different countries had different weighing systems. So this was creating a problem for many peoples, for many workers, trader, and businessmen. So this is the reason to make this international system accepted for measurement. This international measurement system.
Right. So well said. Scientific, international usage in scientific, technical, industrial, and commercial work.
Hmm.
So the scheme is now for international usage. Internationally, it's the scheme is now available for scientific, technical, industrial, and commercial work. So
Yes,
the example that you described is commercial work. So pretty well
commercial
identified.
work.
Yeah. So I'll
Hmm.
give you one scientific example. There was this satellite.
Okay.
Yeah, there was this satellite which was sent. It's a very crazy story. Like some accident happened uh, when satellite was re-entering or something. So I'll have to find out that story and
Hmm.
let you know. So in that story, what happened was this satellite was running on a real-time operating system called VxWorks, and
Okay.
in that system, uh, two different components were developed by different countries, and their system of units for measurement were different. So this operating system was like a real-time operating system, so very small capacity, right? Because it's a
Yes,
satellite,
ma'am.
it is traveling, so it has to
Hmm.
work with very small amount of memory and processing. So the
Hmm.
conversion was inaccurate, and because of that inaccuracy, the accident happened. So big
Oh,
accidents can also happen if there is no internationally accepted system of unit which is very accurate. Accurate, it should be
okay.
accurate,
Hmm.
certain. So that's why the certain word is important. It should be accurate, certain, internationally accepted, And we'll come to know
Mm-hmm.
that precision is very important also. We'll come to know about that later. So yeah, that is one another
Okay.
example. And these are,
Okay.
so if you have to kind of see, there are different, so French is also close to English only, System International Unit 1971. So adding this accent and all, it's System International Units. I don't know why they call this, but it's a nomenclature, internationally accepted, so it's well accepted.
Hmm.
General Conference on Weights happened in November 2018, so not very far ago, recently, right?
Okay. Okay. Yes, Monk.
Hmm. So now in this paragraph, they are saying that it's internationally accepted. There were three, centimeter gram second, foot
Hmm.
pound second, meter kilogram second. And now internationally they have accepted something, and now they take it like a SI standard. That's what they are saying. And because SI units used decimal system, so using decimal system is convenient, like describing numbers with 0 to 9. So that is decimal system. Convergence within the system was quite simple and convenient, and that's why we shall follow the SI units in this book. So in this book, we'll be using SI units, right?
Ha ha.
So, there are seven base units. Now I'll let you describe this paragraph.
Okay, Monk. So, yeah, in SI unit there are seven base units as given. Monk, to describe this paragraph, I need to see the table, the
Yeah, yeah,
seven base units table.
right. You will see the table. Table is right here.
Hmm.
But first, read the
Hmm.
paragraph and describe it without looking deep into the table.
Okay. So beside the seven base units, there are two more units that are defined for A plane angle. Yeah. So among there are total seven units. Okay, to describe the measurement or these scientific, technical, industrial, commercial work. All these work to describe there are only seven units. But beside these units, uh, except these seven units, there are two more units. That's there are two more units which can be defined as first plane angle d theta. In this d theta, yeah, there is a diagram too. D
Right.
theta is equal to ds upon r radian. Yeah, and ds upon r radian. Oh, okay, Mangan understood. And as the ratio of length of arc, ds is the radius of r and b, sorry, d. Monk, uh, yeah, the in this yeah, fifth line after the angle word D. What is this sign?
This is d omega.
Yes, omega. Okay, monk. So I can't explain this in a very simple or very detailed way because I'm confused to understand this.
See, it's simply describing the same thing. This formula, it's describing that.
Hmm,
Besides
hmm,
the
hmm.
seven base units, so we already know that there are base units and there are derived units, right?
Okay.
So there are seven base units, and besides the seven base units, there are two more units that are defined
Hmm,
for plane angle d theta. So d theta is another unit that's defined,
hmm.
and it's it's defined in terms of radian. So unit name is radian. So plane
Okay.
angle d theta is the ratio means division, like numerator upon denominator of
Denominator. Yeah.
arc ds. Arc ds is this is arc
Yes, monk. Understood.
ds to the radius r. Ratio is that defined like that. Arc ds by radius r. And second b is solid angle d omega. This is solid angle d omega, right?
Okay.
This is solid object.
Hmm.
So it's like a conic section, but not exactly. So
Okay.
this
Okay.
d omega is defined as the ratio of intercepted area dA. Intercepted area. So this area is somehow measured and is termed as dA. We'll know about small d later. But imagine that this
Okay.
is a small area. Intercepted
Hmm.
area dA of the spherical surface. This is a spherical surface, like a section of a ball or earth.
Okay. Hmm.
Described about the apex O. This is apex O, kind of a point of reference
Hmm.
as the center. So this area is centered about this O, apex. So this area divided by, this area is the numerator to the square of its radius r. So this is the radius r, and the square of the radius you put it in the denominator at that ratio. It has a unit of, so in the next sentence they say that the radian, the unit for this d theta is radian, a unit for this d omega is steradian, right?
Hmm. 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 Okay.
And both these are dimensionless quantities. So we'll know about dimensionless quantities later. So the things that we
Hmm.
have to know about later, we'll take a note here, right? The things that we
Okay.
do not understand well.
Hmm.
So what is dA? What is dA, right?
Okay.
And
Yeah,
similarly,
just DA,
hmm,
those DA and DS parts.
right. So dA and ds.
Hmm.
dA क्या है and ds क्या है? This is one question. And any other question you have in your mind?
Yeah, Monk, and in the previous page. Yeah, and just scroll up, scroll up. In this, I need to more specific about these derived units, base units, and system units. These three things.
Okay. So base units, as we see, they have defined here, like length. So base quantity. Base
Mm-hmm.
quantity, if it is length that we are measuring, then the base unit is meter for that.
Okay.
So base unit is meter. Here mass kilogram times second. Electricity for electric, it's ampere. For
Hmm.
thermodynamic temperature, Kelvin. For amount of
Kelvin.
substance, mole. For
Mole.
luminous intensity, candela.
Candela.
You
Hmm.
don't have to memorize any of these things because it's written here. The values mentioned here need not be remembered or asked in a test. They will not ask you these things in a test, right? They will not ask you
Yes, ma'am.
to memorize these numbers. They are given here only to indicate the extent of accuracy to which they are measured, right?
Hmm.
So we
Okay.
measure units to very accurate numbers. So units are very certain and very specific. And accuracy part is close to certain part here, right?
Hmm.
So T certain. So with progress in technology, the measuring techniques get improved, leading to measurements with greater precision. The definitions of base units are revised to keep up with this progress. So these are the definitions of base units. You see how they are defined, right?
Okay.
So you can
Hmm.
take it as an exercise, as an assignment to read about
Okay.
these, like how these base units are defined. So assignment two.
Hmm. Done. Monk, share this PDF after the class, please.
Hmm. Read the definitions, understand, and ask questions in the next class, right?
Hmm.
So I have done some of my own study regarding this. So I'll tell you about this. So meter is uh, meter is base unit. So I'll give you an example of derived unit also to let you know how does derived unit look like, right? We employ units
Hmm.
for some physical quantities that can be derived from seven base units. Are you able to see this?
Yeah, Monk, I can.
So let me show you this again. So we'll talk about derived units in Appendix A6, right? Let's take examples of these to understand it better. So to understand
Okay,
it
okay.
better, let's open the appendix. And in the appendix, you see A6. Let's go to A6.
Okay.
A6. So area. Area is another dimension. We'll know about the word dimension. You heard the word dimension, right?
Yes, Monk, I heard.
So dimension is something which we don't know yet. So in the next few
Hmm.
paragraphs, we'll know about dimension. So area, for describing area, the derived unit is meter square. You see, meter square.
Yeah, yeah.
So see, some SI derived units expressed in SI base units. See, some
Hmm.
derived units are expressed in base units. So
Okay.
derived unit area is mentioned in meter square in terms of base unit, right? Volume,
Okay.
derived unit, described in terms of meter cube. So this is what the
Meter
example of
cube.
derived unit is. And base
Hmm.
unit is meter, derived unit is meter cube, meter square, meter per second, radian per second. So all these kind of things.
Hmm.
You got the example?
Okay, Monk. I saw them.
Okay, now I'll stop sharing here and start sharing the other part. I think this is the last part of the class, last 5 minutes.
Hmm.
So we'll try to wrap up quickly, right?
Oh, yes, yes.
So for the remaining part till here, you should read and come up with questions, as many questions as possible. So 1.2
Hmm.
in this class, we can consider that 1.2 is finished pending Q&A. So we'll have a Q&A in
Okay.
which you'll ask about all the questions that you have from 1.1 to
Hmm. All
1.2,
the doubts. Yes,
all
Monk.
the doubts, right?
Hmm.
So I'll share this with you. I'll share this file with you. And how do I do that? I'll share that information right here. So you see
Hmm.
in
Hmm.
this, how you see this file is Inkscape file, right?
Hmm.
It's a SVG file,
Yes, Monk. XVG.
and
So.
it is the same file that
Hmm.
NCERT has, but it does not have this watermark. You see, there's no watermark.
Huh.
And in the NCERT book, they have this watermark, copyright not
Yeah,
published,
there is a watermark. NCRT. Not to be in sale. Yeah, there are some watermarks.
right? So to bring this book to here and add notes,
Hmm.
uh, I have made it
Okay.
such that I can add notes here. So I added
Hmm.
a lot of notes about this section 1.1 and section 1.2. So when you come across this page, when I send you this, so you can use these, read these, and then try to explore around and then come up with more questions, right?
Hmm.
So
Yes.
how did I make this? I'll show you that quickly and then we'll wrap up. So I'll
Okay.
stop sharing here and I'll start sharing my code. So now what I'll share is my code right here. So you see, this is the code.
Yes, Monk.
So what I did was I downloaded that book, download the whole complete book, right? So it has all the
Hmm.
PDFs.
Hmm. Okay.
So these are all the chapters and all. And I
Hmm.
use this code to convert PDF to SVGs.
Monk,
And
you freeze. Oh, you came back.
okay, so I use this code to get the SVG file from PDF. So
Hmm.
SVG file look like this. And when I open the SVG file in Inkscape, I see that watermark and I have deleted that. So that's why you can't see it here. So I deleted that watermark. And
Hmm.
after deleting those watermark manually, so I had to do it manually, right? Because I still have to automate that part. So once these SVGs are generated, I manually deleted those watermark, and after that, I'll combine the SVGs into one file. I'll use this code
Hmm.
to do that
Okay.
with 300
Oh,
DPI uh, dimensions per
DPI
pixel.
means.
So I think
Okay.
depth per
Okay.
pixel or dimension per pixel per inch, something per inch, right? So I
Hmm.
don't know. I have to find out. DPI is something about resolution, how sharp, how clear that image is. And after
Hmm.
this, the PDF is generated. So and that's how I created that. And once that is
Hmm.
generated, I can I can actually put it in the form of a PDF. right?
Yeah.
So that PDF will be, but that PDF came out to be like not of good quality, so I kind of went ahead with creating my own Inkscape file manually. So now what I'll do is I'll add these code into our GitHub repository so that you'll have access to the Inkscape file, right? So let me do
Mm-hmm.
that. So let me do that right in front of you. So I'll stop sharing here. I'll take last couple of minutes. I'll start
Okay.
sharing my terminal window. So let's
Hmm.
go at terminal. I can actually do it right here also in the same thing. So let's do that. So let's go to coding part, terminal, show terminal, new terminal,
Hmm.
and here.